Good morning. Today we will study about long form periodic table. What is long form periodic table? What are the characteristics of long form periodic table or modern periodic table? As we know, there are more than 100 elements. There are 118 elements so far discovered. How these various elements are arranged in the periodic table. Okay, the long form periodic table is based on Moseley or modern periodic law. What is modern periodic law or what is defined Moseley periodic law? The chemical and physical properties of elements or the periodic functions of their atomic number. Okay, remember the properties of elements, physical and chemical properties of the elements are the periodic functions of their atomic number. Whereas Mendeleev periodic table, in Mendeleev periodic table, properties of elements are the periodic functions of their atomic masses. Okay, he proposed this periodic law after doing this experiment. He carried out this experiment when strong electron beam is bombarded on metal target. When electron beam is bombarded on metal target, X-rays are produced. With the frequency nu. What is the frequency of the X-ray? Nu. Okay. The square root of the frequency of X-ray emitted is directly proportional to its atomic number. It's proportional to its atomic number. Okay. Therefore, he proposed this modern periodic law. Okay. The properties of elements depend on their atomic number, not on their atomic masses. Okay. So on plotting square root of nu versus z, a straight line is obtained and thus a straight line equation where a and b are constants. So the third point is based on the electronic configuration or electronic arrangement, the elements are arranged in the periodic table. Okay, how the electrons are built up? How the electrons are built up in atom or element? Okay, using AUFBAU diagram, you have studied earlier. What is AUFBAU principle? According to AUFBAU principle, this is build up. In German, AUFBAU means build up principle. According to AUFBAU principle, the electrons are filled in the orbitals, the various orbitals, in the increasing order of their energies. For example, 1s first period, 1s2 is filled. Okay, 1s2. Therefore, there are two elements. And in the second period, 2s2, 2p6, therefore 2s2, 2p6, 8 elements are there. Next 3s2, 3p6, again 3s2, 3p6, 8 elements. And next 4s2, 3d, listen here, 4s2, 3d, 10, 4p6, therefore 18 elements. Okay, similarly 5s2, 5d, 10, 5p6, 18 elements. Next 6s2, 4s14, 5d10 and 6p6, therefore there are 32 elements. And next similarly 7s2, 5f14 and 60, they are incomplete. The period is the seventh period. There are, therefore, based on the electronic configuration, the modern periodic table is built. Okay, remember, based on AUFBAU diagram, this is obtained, and based on this configuration is this modern periodic table is constructed. Okay, now for example here one hydrogen and helium, and therefore 1s, 2s, 3s, and then 2p, 3p, 4p, 5p, 6p, 7p, etc. Okay, so you have and next you have d orbitals are filled, 3d, 4d, 5d, 6d, etc. and 5 of and the f block elements are placed at the bottom because you cannot insert the f block elements here, otherwise the periodic table will be destroyed. Integrity of the periodic table will be destroyed. Therefore, they are placed at the bottom of the periodic table. Let us. This is the brief outline of the modern periodic table based on the electronic arrangement. Okay. So let us see now. There are 7 periods. Fourth point. There are 7 periods. The horizontal rows. See, this is horizontal rows. The horizontal rows are called periods. There are 7 periods. The 7th period is incomplete. Okay. And there are how many vertical columns? 1, 2, 10, 60. So 18. There are 18 vertical columns called groups. The vertical columns are groups. There are 18 vertical columns. Okay. Now, based on the electronic configuration, the modern periodic table is classified into 4 types of elements. There are 4 types of elements based on the electronic configuration arrangement in the periodic table. They are S block elements. S block elements. The last added electron goes to S orbital, the NS orbital, and in P block elements, D block elements, and F block elements. In the case of P block elements, the last added electron goes to the P orbital, NS2, NP 1 - 6. This is the general electronic configuration, and the general electronic configuration for the D block element is N - 1 D. The last added electron goes to the penultimate. Penultimate means that is last before one. Last before one, and penultimate orbital. And this is in the case of F block element NS2. The last added electron goes to the F orbital. F orbital. There are 7 F orbitals. Therefore, there are 14 elements. There are 14 elements. 1s orbital, only one. P orbital, Px, Py. It is triply degenerate, and this is there are 5 d orbitals. There are 7 f orbitals. Therefore, 14 elements. Here 5 d orbitals. Therefore, 10 elements. 3 p orbitals. Therefore, 6 elements. Okay. So f block elements are also called inner transition elements because the last added electron goes to the inner f orbital, okay. Therefore, they are called inner transition elements. The D block elements are called transition elements, and S block elements are called alkaline earth, alkali metals, and alkaline earth metals are called S block elements. Okay, so you have P block elements. Okay, now this is the characteristics of important characteristics of the long form modern periodic table. So please understand and you write down the notes also. Thank you for watching.